Today we're looking at Glencoe Course 2 Math, Lesson 6-1 on adding and subtracting, being involved in one-step equations. So we're starting at page 438. If we are looking at a one-step equation, that means that there's only one thing we have to do to solve for our variable. So when we were working with our expressions, we said that we could only simplify. We can't solve for anything. We can't figure out what that variable is equal to. This chapter is all about equations, so this time the goal is to get the variable by itself on one side of the equal sign and a number on the other so that we can figure out what that variable, what quantity that variable represents. So let's look at what that might look like. If I look at example 1, example 1 says x plus 6 equals 4. Now, we are actually using the subtraction property of equality. What that means is that if we have a positive and we subtract it by the negative, by a negative of the same amount, or if we subtract by that same amount, we get to 0, correct? Okay, we're trying to get this variable by itself, which means we have to add 0 to it to get our answer. So if we start by taking x plus 6, to get that variable by itself, we're going to do the opposite, which says we subtract 6 on both sides. 6 minus 6 is 0, so I'm left with x. 4 minus 6, or 4 plus a negative 6, is negative 2. So that means that x, this time, is equal to negative 2. Is this something that we've seen before?
Yes.
Is this something that we remember how to do?
No.
No,
Kind of, maybe?
Maybe.
Maybe kind of.
Okay. So let's look at another example. Because this time we have to do it when there's a negative involved. Negative 5 equals b plus 8. Negative 5 equals b plus 8. So first of all, does it matter whether my variable is on the right or on the left?
No.
Does it matter?
No.
No.
Yes, it does.
No, it doesn't.
She said no.
So, while we may have a preference of one side over the other, it really doesn't matter. It really doesn't matter. The variable can be on either side. What I am going to tell you though is don't just move it to the other side. Don't rewrite this problem backwards because you like the variable on the left. Because while we can do that, the math behind it we're not ready for yet. Okay? So leave it as is. It's okay. Alright. In this situation, I have to get the variable b by itself. So to get b by itself, what number do I have to get rid of?
8.
I have to get rid of the 8. How do I get rid of a positive 8? I subtract 8 from both sides. Okay? What is negative 5 minus 8, or negative 5 plus a negative 8? Ooh. I'm going to go ahead and write that as plus a negative for us. So negative 5 plus negative 8. What did our rules of integers tell us to do?
3. No. Negative 5 plus negative 8.
If the signs are the same, we add the numbers and keep the signs. That's what our rules of integers tell us. So what is 5 plus 8? 13. Is that 13 going to be positive or negative?
5. Negative.
Negative. Because if our terms are negative, our solution will be negative. Okay? Questions about that? Alright? Let's look at the other side of things. let's say that instead of starting with a problem where we have addition, we had subtraction. Looking at example 4, I have x minus 2 equals 1. So, excuse me.
Yes.
Here, to get the variable by itself, we started out with addition. We did the opposite, which is subtraction, to get to our answer. If I start with subtraction here, what am I going to do to get to 0?
Add.
Add, okay? So I know that I have to add to both sides. What I do to one side, I have to do to the other. That's what makes it equal, okay? Do any of you guys know little kids, like 3 or 4 years old?
Yeah.
Okay. Can you give one of them a piece of candy without giving the other one one?
No.
Okay? Let me rephrase. You could, but it's not going to go very well, is it? Okay? So, if you have 2 kids that are 4 or 5, you have to do the same thing for both of them. They both have to have the same number of nuggets. They both have to have the same number of fries. Everything has to be the same, right? Okay. What we do to one side of equals, we have to do to the other side. Otherwise, we're going to have a cranky toddler running around, making everything all upset. Okay? Right, we don't want that. We don't want to have to deal with it. So instead, we're going to do the same thing to both sides. So what am I going to add to both sides to get my variable x by itself? I can't add x, because then I would have 2x minus 2 equals 1 plus x. Then I'd have more x's, not less. I have x minus 2 equals 1. What am I going to add to both sides to get my variable x by itself? My options are either a 2 or a 1. 2. If I have a negative 2 and I add positive 2, I end with 0, correct? Okay, so I'm left with x equals, what is 1 plus 2?
7.
No.
3.
3. What are you doing coming up with 7?
I wasn't thinking of 3.
Okay, you were just random answer? Okay, let's not random answer. Okay, so an x equals 3. If I go back, does 3 minus 2 equal 1?
No.
Yeah. All right. One more for today. Bob 2. Negative 7. Negative 7 equals c minus 6. Stay with me. Stay with me. We're on our last problem.
What are you talking about?
Put it on my desk, please.
You played you want to put your thing like that. Dang.
Can't you get through the last thing?
I'll put it on my
If I have negative 7 equals c minus 6,
Yes.
what do I do to get the variable by itself? Am I going to add or subtract? I'm going to add.
Add. ACA.
Okay? Am I going to add negative 7 or 6?
6.
I'm going to add 6. Okay? What is negative 7 plus 6?
11?
Negative 13.
No, 12.
Negative 13.
You-
negative.
Stop. My answer is going to be negative.
13.
Hold on. My sides are different. So I have 7 negatives, I have 6 positives. When they cancel each other out as 0 pairs, what am I left with? Yes?
Negative 1.
Negative 1, very good.
Oh, I
Negative 1 is equal to C. Okay. Questions? Yes, sir.
Can you do another one?
As soon as the video's over, I will do one more yes.
Can I do the numbers?
Any other questions? Okay.